We light sparklers and crackers during celebrations. Do you think metals can catch fire? It is safe to conduct this experiment in a fume cupboard and using proper goggles and a Bunsen burner. Take magnesium ribbon. Cut a piece of magnesium ribbon. Hold the tip of the magnesium ribbon using a pair of tongs. Burn it in a Bunsen flame. The tip of the magnesium ribbon burns with brilliant white light. The ash collected on the tray is magnesium oxide. Metal combines with oxygen to give metal oxide. When we heat copper in air, it combines with oxygen and becomes black copper oxide. Similarly, aluminium reacts with oxygen and forms aluminium oxide, also called alumina. On exposure to air, aluminium forms a white layer because of its reaction with oxygen. This white layer is a layer of aluminium oxide, also called white rust. This oxide coat over aluminium protects the metal from further rusting or corrosion. Anodizing is a technique of protecting aluminium by forming aluminium oxide electrochemically. The aluminium object to be protected is made the anode, and another aluminium plate is kept as the cathode. Sulfuric acid is the electrolyte. When a current of suitable voltage is passed through the metal, oxygen is evolved at the surface of the anode and forms a white film of aluminium oxide. This white layer of alumina is porous and adsorbs dyes of attractive colors. We can hardly avoid anodized aluminium articles in our daily life. Your mobile phone is also made of anodized aluminium. What is the nature of this metal oxide? Metallic oxide is basic in nature since it reacts with acid. Example, copper oxide. Alumina reacts with acids and also with bases. That is why aluminium oxide is amphoteric, that is, it is acidic as well as basic. Let's consider gold first. Drop the gold ring into the water. Nothing occurs. Let's drop a piece of sodium metal. Metals are arranged in a table, the activity series according to their reactivity. Potassium and sodium are at the top because they are the most reactive metals. Gold and platinum are at the bottom because of their low reactivity. Metal reacts with water to give metal hydroxide and hydrogen gas. Potassium reacts violently with water to give potassium hydroxide and hydrogen gas. Similarly, sodium reacts with water to give sodium hydroxide and hydrogen gas. Hence, we should keep them away from air and water. Can you guess how we can protect sodium and potassium from moisture and aerial attack? We keep potassium and sodium immersed in kerosene. In this way, we can prevent them from coming into contact with moisture and air. Calcium reacts with water to give calcium hydroxide. Magnesium reacts with cold water slowly, but reacts with steam aggressively. Aluminum, zinc, and iron react slowly with steam. Silver and copper do not react with water, but are affected by air. Gold is not affected by water or air. Non-metals are not affected by water. Example, sulfur and phosphorus. Iron reacts with steam to form iron oxide and hydrogen. Let us perform an experiment to understand how different substances react with dilute hydrochloric acid. Take samples of magnesium, copper, and sulfur powder in different test tubes. Add 5 ml of dilute hydrochloric acid to each of the test tubes. After a few minutes, bring a burning matchstick near the mouth of each test tube. What is your inference from this experiment? Not all metals react the same way with hydrochloric acid. When the matchstick was brought near the test tube containing magnesium, there was a pop sound before the flame went out. Magnesium reacted with the acid to produce magnesium chloride, a salt. Hydrogen gas Most metals react with sulfuric acid to give metal sulfates and hydrogen gas. For example, copper reacts with sulfuric acid to give copper sulfate and water and liberates sulfur dioxide gas. Watch this experiment. You can see copper reacting vigorously with nitric acid. It forms an irritating brown gas. It is poisonous nitrogen dioxide. Experiments of this type must be conducted only in a fume cupboard. When the solution is further diluted with water, it develops into a blue solution of copper nitrate. Copper is oxidized and nitric acid is reduced in this reaction. Gold is dissolved neither in concentrated hydrochloric acid nor in concentrated nitric acid, but in aqua regia. It is a freshly prepared mixture of concentrated hydrochloric acid and concentrated nitric acid in a 3:1 ratio. Aqua regia is also called royal water, since it dissolves the royal metal gold.